Okay everyone, welcome back to another video. Today I have a trig sub past paper question for IB Maths AAHL. And just a disclaimer, this video is only meant for people who have some sort of mastery or experience in trig substitution. If you do not and you're a novice, please check out the video linked in the description. And let's begin. Okay, whenever we have a trig sub question, what I like to do is write down what we're given, okay? So we have the integral of dx over x squared times square root of x squared plus 4. And our substitution is x is equal to 2 tan u, where we're assuming u is an angle. So what I'd like to do is draw a right triangle, start off with, and we have an angle u. So since we are adding x squared and 4, this is a tan substitution, which is evident in the question. So we can say one of our legs will be x and the other will be 2. Therefore, the hypotenuse is just the square root of x squared plus 4. So tan u is x over 2. X is 2 tan u. Differentiate x with respect to u. We get, I believe, 2 secant squared u. Let me just double check if that is correct. The formula booklet. Yes, it is correct. And then we solve for dx. So dx is 2 secant squared u du. Perfect. And now we make that substitution for x and dx. So we have dx, which is 2 secant squared u du over x squared, which is 4 tan squared u times the square root of that plus 4. Tan squared u plus 4. So the next step, as I mentioned in my previous video, linked in the description, we need to just factorize whatever is in the square root, because we are going to use some sort of trig identity to break it down. And I believe tan squared theta plus 1 is just secant squared again. Let me just verify if that's true. The formula booklet. Tan squared plus 1 is indeed secant squared. So we get 4 secant squared u. And I apologize if I'm going a bit too fast. I just don't want this video to be long like the previous video. So yeah. And I want to simulate an IB environment where I need to solve this as fast as possible. But obviously that won't happen, as I'll explain the concepts going on. So we've got the square root of 4 secant squared u, which simplifies to the integral of that times 2 secant u. Perfect. The 2's will cancel out. Secant u will cancel out as well. So you're left with secant u du over 4 tan squared u, and we can move the 1 over 4 outside the integral. Secant u du over tan squared u. Okay. Now the next step is to recognize that secant u can be written as 1 over cos u. And tan squared u can be written as cosine squared u over sine squared u. I apologize, that's 1 over tan squared u. So secant u over tan squared u would be 1 over cosine u multiplied by 1 over tan squared u, which is just cosine squared u over sine squared u, which will give us cosine u over sine squared u. So we are left with 1/4 times the integral of cos u over sine squared u du. Now, we need to make another substitution. So this will be like a u substitution, but we're not going to use u. We can just use a variable v instead. So say v is equal to sine u. dv over du is equal to cosine of u, which means du, which we'll substitute in our integral up here, so this integral, is equal to dv over cosine u. And why this is nice is because it will cancel out with the numerator in the integral. So cosine u over v squared multiplied by dv over cosine u. So now we are just left with an integral that has a variable v, which we will integrate. So 1/4 times the integral of v to the power of negative 2 dv is equal to 1/4 times negative 1 over v, which is negative 1 over 4v plus c. Nice. And we substitute v for sine u, so this is equal to negative 1 over 4 sine u. And we are almost done, because we know that sine u is equal to, if we go up to the triangle, it is equal to our opposite, which is x, over our hypotenuse, which is root x squared plus 4. So that is x over root x squared plus 4. So our final answer, like, times 1 over sine u, which will be the inverse, so square root of x squared plus 4 over x. I just make that negative root x squared plus 4 over 4x plus c. And this is our final answer. And let's check if it's equal to what the question asks. Yes, it is. So, just to recap, essentially, I followed the same process I did for other trig sub questions, and this is the procedure that you want to use to guarantee an optimal amount of marks per trig sub question. You start by writing down everything you have, creating a right angle triangle, and laying out the information you have, making your substitution, finding the derivative of it, manipulating whatever is inside your integral, and if need be, you are going to need to use a variable substitution, as we did with v over here. There are probably other ways in which you could solve this, in the sense that you could you could separate cosine u, sine squared u. You could use an identity that has sine squared u and integrate that without the need of a v substitution. But anyways, we stuck with that and we ultimately got the answer. Thank you, and if you're interested, please leave a comment, like, and subscribe.